manera, que no
All right.
lo ven.
So I will tell you that all of the parts here are either from a washing machine or from a dryer. Okay, there are no other appliances. They could be found in other appliances, like that part could be in another appliance, that one. A few of these could be in another appliance. So let's first go and identify what each part is. Okay, starting up here, what is this part? Okay, it's a motor, and Paul, you said it's for a dryer. Why did you say it's for a dryer? You are correct, it is for a dryer, but do I have another motor over here?
Here, that's not for a dryer.
Well, how do you know whether it's for a dryer or not?
It's not designed for a belt.
The belt.
The belt, this one is designed for a belt.
Yeah, but some machines, like a washing machine motor, will have a pulley that has an Allen key or something that screws it to the shaft. Sometimes when you buy a replacement motor, you have to take the pulley off of one motor and put it on another. So just because it runs off a belt, don't washing machines use belts?
Yeah, but, this one,
Which one? This one or that one?
this one over here, dryer,
Okay.
you can look at it and tell that, it's for a dryer.
But what is telling you it's for a dryer? That's what I'm trying to understand.
Okay.
Everybody else here doesn't know what you're seeing, and they're like, well, how do you know it's for a dryer?
Sí, porque el otro vendíamos.
It's the, I don't know the name of the part, that's sticking out for the belt.
Well, this is the pulley for the belt.
Right.
What goes on the other end?
It's the,
Francois just worked on a dryer
I don't
yesterday.
the name of it, I know it, I helped
Do
you put
you
it
guys
on.
know? Come on, you guys been through dryers. What goes, the belt goes here on the dryer. What goes on the other end of the dryer?
El otro lado que va.
The blower fan.
Low fan.
The fan that circulates air inside the machine. It's connected to the other side. Now this motor has two shafts, right?
Right.
Yeah.
This motor has two shafts. You don't see it, but just barely it's sticking out. So just because it has two shafts doesn't identify whether it's a washer or a dryer. But one thing we can look at is how many different color wires are right there. I'll make it bigger for some of you who can't see it.
Yeah.
Now some of you, if you want to get closer, you can get closer. How many wires are there?
Is it three?
3 wires, right? You got white, brown, and blue, right? Okay. Let's take a look at this other motor for a second. This one. How many wires do we have there?
Looks five.
5?
Four.
1, 2, 3, 4, 5, 6. We have 6 wires. What's different between those two motors besides what you physically see in their size? What is different from the two, a washer motor and a dryer motor?
Smaller, a little bit bigger.
Well, I said different from the size. Well, the casing's a little different, but the wires are different. So what do you think the wires mean? Yeah, Corey.
The wires mean speed. The speed
Okay.
wire.
So this one here with just 3 wires, what do you think that is?
Because it goes a little slower. than
Single
the
speed motor.
It's not the speed, like, you can't say this one's faster than that one, but yes, a dryer does go slower. Okay?
The amps.
Well, by the wires, we can determine how many windings are inside. Yes, sir.
I think it's different cycle.
What do you mean by cycle?
Cycle,
Are you talking about like a washing machine where it washes but it spins?
correct.
You're sort of right on that, because on this machine here, the difference in wires are the amount of electrical windings inside the motor. And I'm gonna show you in the schematic in a minute, but first let's just identify the parts. But in this case, a dryer motor, all except for one brand, I've seen that dryer motors are always one speed and one direction. The motor only goes clockwise or counterclockwise. Most motors go clockwise, but the drum runs counterclockwise. It's depending on the orientation of the drum. But this has 3 windings. One of them is called the run winding, which runs the motor. The other one's the start winding, which helps the motor get started. That's 2 of the 3 wires, and they both go to a single wire, what we call a common terminal. I'll show you in a diagram. But this one here has got a start winding, but it also has 2 speeds. So a dryer has 2 windings, start and run. That's it. It runs at 1 speed or it's off. This one here, not only does it have 2 speeds, high and low, but it also is reversible. It goes one way for wash and the other way for spin. And that's why we have so many wires. On a 2-speed reversible motor, we're going to have 6 wires. How many wires do you think a 1-speed reversible motor would have? 5. Only because the 2 windings have a single common point. Okay? But the start winding on this one is separate from the rest of the winding. We'll look at that in the diagram in a little bit. I'll bring it up, but I want to go through all the parts here first. So this is a washer motor, this is a dryer motor. So what I'm going to do is I'm going to start moving parts, like the stuff over here is the washer, stuff over here is the dryer, okay? So this is the washer motor, and I'll put dryer here and W here for washer. What is this part?
Thermostat.
But what
The dryer.
machine?
For the dryer.
Dryer, okay. So what type of thermostat is that?
It's either the regular, it's either a fuse for I can't think of the name right now. The element, the heating element, or is a safety, for a high temperature or low.
It's for the heating element. Okay.
Not to get too hot.
Now the problem is that little pin right there is blocking some very key information here. That right there, you see like the 1, and that's a 5, and it says F, that's probably a 3. 3 or a 4. It's either 135 or 145 degrees Fahrenheit. That is the temperature at which that switch is going to open and close. Okay? So that is what we call an operating thermostat, because that is the operational temperature of the dryer to dry close. We dry at 140 to 160 on high heat. Okay? But there's something a little bit more about that thermostat, because a thermostat, if we looked at the symbol of a thermostat, it's like this. Now the circles represent where you connect the wires. Okay? But that's only 2 terminals. How many electrical terminals do we have on that thermostat? 4. So what are the other 2 for?
It's the, I don't know how to see it, but it's like the wire on top.
It has more wires, but what is, okay, I'm gonna tell you right now, let me get the 2 larger terminals are where power goes in and goes through and comes out the other side to the heating element. Okay? And when it reaches a temperature, the switch inside is gonna open, the heater shuts off. And it's gonna shut off at, let's say, 135 degrees. And then that switch opens, what happens? The heater's not running anymore, so what happens to the temperature in the dryer? Starts dropping once the heater's off. This switch is going to close again, and the heater's gonna come on, and we're gonna keep an average temperature. Okay? So this is a cycling thermostat, but these 2 smaller terminals are called a thermostat heater or a bias heater, B-I-A-S. A bias heater is inside that thermostat, there's a little heating element. Let me change my drawing here. Inside the thermostat's a little heating element, that's a symbol for a resistor or a heater. And if I turn that on, normally this switch by itself is 135 degrees. But if I turn that heater on, the heat is inside the thermostat. It's between those 2 little terminals there, a little tiny piece. And it makes the inside of that thermostat warm and causes the switch to open prematurely. Now, prematurely, I mean, instead of opening at 135, it may open at 125. And by doing that, we can make a single thermostat work on high heat by leaving this off and cycle on and off at 135. But if I turn that heater on, now it's cycling on and off at 125. So back in the day when they made these dryers, when I started working in the 80s, I was working on dryers as far back as the 60s. And they had 3 different thermostats on the back. One for high, one for medium, and one for low. Because, you know, our clothes, you know, we're all guys in here. We wear heavy jean, cotton clothes, we're gonna dry everything on high. But women's garments and some guys' shirts and stuff like that, if you dry it on high, it's gonna shrink, it's gonna damage it. So we have to run at lower heat so we can take care of the clothes. So back in the day, we had a switch and we said, go through this thermostat to control the heater, we got high heat, go through that thermostat, and then we got low heat. In this case here, they said, well, we can use one thermostat, but depending on how much power we put here, we could actually get 3 or 4 different heats. I could put 60 volts here and it will cycle it, but if I put 120 volts, it'll cycle it at even lower temperature because the higher voltage is going to cause more heat and trick that thermostat at a lower temp. Okay, so this is part of what? Washer, dryer? Dryer. Okay, so I'll put it over here by the D. Right? What is this?
Timer,
Okay.
timer motor.
What does a timer do?
Control the cycles.
Okay, but the timer motor is on the back side there. It's a little hard to see, but that is a timer which controls the whole machine function. It's like your brain. Now most of our machines, instead of having a mechanical timer, they use what?
Timer motor.
Electronic.
Computer board. Instead of a mechanical timer with switches, now we got a computer that has relays on it that open and close and turn it on and turn it off, right? So that is a timer for what? The washer or dryer?
Drying.
It's a washer timer.
The washer.
Yes. And the only way you're gonna know is like, you see all these pins on top? There's 3 rows of those pins. There's one on the top, middle, and bottom. We're not gonna talk about that today, but the next lecture we're gonna talk about the actual chart and how to read that. But that right there has so many pins, dryers don't have that many parts in them. You know what I mean? Washers do. They have water valves, they have electric drain pumps, they have the motor, they have, you name it. They have solenoids for dispensers, and they have a lock mechanism. They gotta control a bunch more parts that a dryer doesn't have to control. Yes, sir?
That was a trick picture anyway, because you can't see the pins on the side, even take the washer.
Well, if you worked on enough washers, you'd recognize the part, right? Is that a trick question?
Yeah,
Or just you ain't got there yet?
I didn't see the pin.
Okay, but if that's a washer timer, we'll put it over here. And I'm gonna erase this stuff here so we have room. So how about another trick? What is that?
The dryer
That's a dryer what?
time.
That is the timer for the dryer. Has a lot less pins and connectors. And here you can see the timer motor on the timer because it has a picture of the backside. But these pins here, we only have a few because we're controlling a heating element, a motor, maybe a light bulb, maybe the buzzer at the end of the cycle. It's got a buzz, so we got to hook that thing up. So that's why we have a few extra things. We have a switch in there that controls the timer motor because we have different cycles to make that motor run or cycle on and off or something like that. So it has a lot less connectors for it. So this is part of the dryer, and I'm going to move it over here with the dryer. So what's this part?
The actual motor.
Okay.
That's the only from the dry shop. Pressure.
Pressure switch,
Switch.
or we also call them water level switches. Now, this has changed back in the days. A water level switch has 2 positions, empty and full. Right now it's making connection to empty, and when the machine fills up with water, some of you guys like working on the washer you guys were working on the other day. Remember I said that clear hose had to be connected to the tank?
Oh, yeah.
So on the washing machines, they have a little hose that runs down to the tank where the clothes go, and as the machine fills up with water, the side of the tank traps air. And as the water goes higher, it's trying to push the air up through the hose, which cycles a switch here, a pressure switch. So right here is where that hose connects, and in that big circle is a rubber diaphragm, and when the air pushes, the diaphragm cycles a switch, open and closed. So what is this used for? Water level. Does the motor run while we're filling up with water?
No.
So it's controlling the motor, right? And do we spin with a full tub of water?
No.
So it's also making sure that we don't spin. Why don't we spin with a full tub of water? What? It's going to overflow. It's just like you have a coffee and you're putting sugar in it, but the coffee's right at the top and you're trying to stir it. What's it going to do? It's going to overflow. So the water level switch has a couple of functions, and they're there for different reasons. So this is part of the what? Washer or dryer? Washer. So we'll move it over here with the washer. Okay.
Professor, you put it in dryer.
Yes, I did. I'm sorry. I was in my head. I was thinking of erasing this, and I just dragged it to the wrong side. 1 second here. I need to make room for my parts. So the washer goes over here. I erased my W, didn't I? All right. Let's start with the next part. That one probably none of you have seen yet unless you work with switch. It is a lid switch.
Lid switch.
Door switch and lid switch. They're pretty much the same thing, but if I say lid switch, I'm talking about the top of the washer. When you lift the lid up or lower the lid, it cycles the switch. A door switch is like a dryer or washer
That's a
that you're
lid switch,
opening the front of the machine. Some washers are front load, some washers are top load. This here is unique. You guys are very rarely run into it. Whirlpool came up with this. So you had a lid on a washing machine like this, okay? So let's just say this is your washing machine and your clothes are inside here, the agitator. And you're closing and opening the lid. A lot of times they have a little hole here and a pin here, so when you closed it, it pushed down on the switch. If you opened it, it did this. Well, Whirlpool came up with a new switch. On the back of here, there's like a little hinge, but this hinge went here and then it curved like that. And when you raised and lowered it, when you closed it, part of the metal curve went right inside here and pushed up on the switch from underneath. You wouldn't see that switch. You had to lift up the control panel. It was right there with the control panel. And the reason why they did that one switch was it was easier for the technician to replace. Because the other washer switches were underneath the top, and you had to take the whole cabinet off to get underneath the top to change that switch. And they said, oh, this one here, 2 screws, we flip the control panel, it's right there. It does the same thing. It's a safety so that the machine doesn't run with the lid open.
Yeah.
Okay? So is this washer or dryer?
Washer.
Washer. Okay. I should ask that first before I gave all my explanation, right?
Yeah.
Okay. Let's
It's a given.
let's go on. What's this?
Relay.
Light?
Relay. Relay.
Relay.
Relay.
No. A relay has how many pieces? ¿Cuánto piezas para relay?
Two.
Está dentro. What two are they?
The resistor or the heater, the solenoid, what's called solenoid?
Solenoid?
Solenoid. And
Switch.
the switch.
So how many circles do I have there?
4.
4. So how many wires am I going to have in that relay?
4.
Yeah.
4. Let's go back to that part. How many wires connect to that part?
2.
So is that a relay?
No.
It looks like a relay.
It's a capacitor, right?
It's not a capacitor. Do you see anything on there that says capacitance?
You can't see
I
it.
can't see.
Okay, I'll make it bigger for you.
Big enough?
Okay, can you read that now? Do you see anything there that says capacitance? Okay, the next question. Am I going to find this on the washer or dryer? I don't know. I don't know what part it is.
Yeah, you can tell.
Might find it on the phone.
On the dryer.
Okay, it's on a dryer. Now, tell me what you think. What do you think it is?
I would say a fuse.
That is the buzzer at the end of the cycle. So when the dryer finishes the cycle, you hear That's what makes that noise.
I thought the buzzer will have something.
No, it has no speaker. It buzzes inside, but it's so loud you hear it.
Yeah.
You know what? Remember the beepers, and you put them on silent. You had it on the table. What it do? Bzzz. That's what that does. That's what that does. That's the end-up cycle. Okay, so what's this?
It's a sensor.
It's the same as that other one, isn't it? It's a thermostat. Why do I say thermostat? Well, wait a minute, before we go further. A thermistor is what? You got that piece? A thermistor is a resistor. When heated or cooled, will change the value. So like at room temperature, maybe 1,000 ohms, but at 100 degrees, it may be 1,500 ohms. So the resistance value changes on temperature, and the computer's always sending a little current, watching it like a meter is testing it, and it knows the temperature based on the resistance value. But this is a switch. Right there it tells you the L means what? What does L mean? The limit. The limit at which the contacts inside open. We have an L here too, but it's just not drawn on the thermostat. But that is a thermostat as well. But what temperature is that one cycle at?
250.
250, and then it opens at 250, it closes when?
80 degrees for
In 100.
Is it 80?
170.
170. Why 170?
Because the difference between 250 and 80.
250 minus 80 is 170. That is when the contact closes back again. That is also a thermostat. Where would I find this part?
washer.
You could find it in a washer, but we don't deal with 250 degrees.
Oh, yeah.
212 is boiling. Could you imagine putting your clothes in? You know what? Just wash your clothes. Just throw it in a pot on the stove and boil it. 212 is boiling. That's 250.
250? Maybe in, what do you call it, a dishwasher or something?
No, that's still too hot.
That's still
Dishwashers only run about 160. So here,
No,
the 250,
Dryer.
it's a dryer.
that much?
It's a safety. So I'm gonna put it over here.
It's a super safety.
So this one's cycling. This is cycling, and that is safety. High limit thermostat. Okay? So what's this part? Someone say something? I didn't hear you.
Yeah. Gene says relay.
And yeah, it is a relay, but what type of relay? I have to give you guys hints, sir.
Yeah.
Post-traumatic syndrome? Yeah.
Do what?
PTS.
PTS syndrome.
Syndrome.
Post-traumatic syndrome, right? No, but that's PTSD.
Yeah.
Push the start switch. That's the button you're pressing to start your dryer. I didn't hear you, I'm sorry. I didn't hear you. You know, when everybody yells at the same time, I only hear what I can hear. So that's a push to start switch. What machine has a push to start switch?
Wash machine, dryer.
Mainly dryers.
I know.
Washers will only have a button to start it, but it will not be a mechanical washer. It will be a computer controlled washer. And it doesn't use a switch like that. It's actually mounted on the main board. So when you're having a button there on a computer one, it's part of the board.
Yeah.
All right? But this is a push to start switch, but it has more than one terminal. It could be a push to start relay, where inside, when you press it, a magnetic coil holds those contacts closed while the dryer is running. Okay? In some of these instances, it has a push button to start the dryer, but it's a momentary contact. We have two different ways to draw it. A one with a relay would just look like this. They have a coil, and then they have a switch here. So when you press it and close it, not only do we complete a circuit to the motor, but it also completes a circuit through the coil, and it holds itself closed. So that's a push to start relay, but a push to start switch is like this. And what does that mean when you see it like that?
A temporary connection.
Yeah, it's called momentary contact. It means it's only making contact while I got my finger on it. When I let go, it opens back up. Okay? But this one having more than just 2 terminals is probably a push to start relay. But the one we have here in class actually had an additional feature to it. If you pressed it, it's to start the dryer. If you turned it, it had an off and on position, and that wasn't to turn the dryer on and off. It was, if you went to the on position, it controlled the buzzer. If you put it to the off position, the buzzer wouldn't buzz at the end of the cycle. Hey, the lady's got 2 children and one's a baby that takes a nap in the afternoon. She doesn't want that buzzer on. Turns the dial, no buzzer. So that's what that piece is. I'll push to start relay. So that's a dryer. Now I'm going to show you, but there's more to it than this. We're first just identifying the parts. What's this?
Looks like
Heating
heating elements.
No, this right here. Is that a heating element?
No.
No, it's a connection to the heating element.
Yeah, but it's a fuse. It's a high temperature.
Wow, 309.
Well, on a Whirlpool dryer, they call it a thermal cutoff, but they also call them thermal fuses.
Yeah.
I will explain the difference between cutoff and fuse in a minute. What temperature does that one cycle at?
I think.
309 says.
Well, I think, look at it,
Oh, yeah,
309. 309.
309 degrees. What machine would we find that on?
Right.
It's also on a dryer. So we're gonna move it over to the dryer.
That's secondary.
So what is this piece?
That's a thermal fuse.
Fuse.
Okay, so this and this, we call this thermal fuse, we call this thermal cutoff. They're both on the same drive. This one controls what? What part in the machine does that control?
Heating element.
The heat element. So what part in the machine does this control?
The drum area where it's inside the.
What's this mean? What's this mean?
The drum.
Not the drum, what makes the drum?
The actual
Fan?
dryer itself inside the temperature.
The motor.
Okay.
Wait,
Dryer motor.
Okay, it's not there, but it's 196 is the temperature. It is to control the motor. If we have an overheating problem, it'll stop the motor from running, nothing will work. So we're gonna put it over here, thermal fuse. Now, why we call one thermal fuse and thermal cutoff, both of them, if they get too hot, they open up, they don't reset. Where a thermostat, when it opens, when it cools down, it closes again. Okay, but these two parts, Whirlpool, when they came out with the machine, they didn't have thermal fuse and thermal cutoffs when I started working. They just had the 2 thermostats. But then they started adding the thermal fuse, then they started adding the thermal cutoff because people were having fires. Their vent wasn't good, the dryers were filled with lint, they started fires and everything else. So UL, Underwriter Laboratory, I think they're the ones who look at product and say, hey, you have to add this for safety reasons. So they added this one to stop the motor and they put this one on the heater. So you might find a dryer from the 70s and you say, hey, it don't have these parts. No. But a lot of the newer machines will at least have a thermal fuse minimum or a thermal cutoff. But Whirlpool, when they put them both in the machine, you know, when I needed a part number, remember, I started in the 80s. We didn't have computers. We didn't have cell phones. You needed a part number. You'd have to call the office and get a part number and a price so you could give the customer an estimate. But if you said, I need a thermal fuse, and they were both called thermal fuse, the guy on the other end in the parts department might look up either one. And you say, yeah, but if I tell him the one for the motor or one for the heater, he's not a technician. He knows what a thermal fuse is. He picks it up and looks at it, yeah, that's a thermal fuse, but he doesn't know how it works in the machine. He's not a trained technician. Okay? So they call them different names. So you say, yeah, I need the thermal cutoff, or I need the thermal fuse. Oh, you need the cutoff? In the parts breakdown, they give it the name cutoff. In the parts breakdown, they call it the fuse. And that's why they did it. They're both the same part, but they named them something different, so when you're calling, you get the right part. They could have the same problem with the thermostats, right? You need the operating thermostat. Well, when they look at the parts breakdown, it actually calls it the thermostat or operating thermostat, but the other one will say high limit. And that's how you would know which one's which. Okay, so we're down to the last row. What is this piece down here at the bottom right?
Heating element for the dryer.
Okay. Does washing machines have heating elements in them?
They could.
Yes, some to heat water.
Yeah, hot water.
We're not gonna put that one in water, are we? No, the ones we put in water look like a heating element inside of a water heater that they can be submerged in water. So this is just a heating element in a dryer, so we'll put it over here. Okay, so we're down to 4 parts. What is this part?
Water valves. Water valves.
Water valve.
Water valves.
Okay? And speaking of that, I didn't put a water pump on here. Okay,
No,
I know why I
water
didn't.
valves,
But
Yeah.
why is it got 2 parts?
One for hot water, one for cold water.
One for hot, one for cold. Well, what if I want warm water?
You put it in the middle.
I put it in the middle. There's no. What do I put in the middle?
I'm just saying.
The hot water has a control on it too.
Let me ask you a question. At my sink over there, I have 2 faucets, hot and cold, right?
Yeah.
I either get hot or I get cold. Can I get
You
warm
turn on
water?
both of
Yeah.
them.
Yeah, you
both
mix
at the
it,
same
you mix
time.
both of them.
The computer.
You turn
Wait,
both of
what
them.
did you
I
say?
said you turn on both at the same time.
But someone said something else. They
The
said
computer will when you
No.
go to.
someone said mix or something.
Mix.
One of you just
Yeah,
said
when you turn both of them and you mix the water.
very good because sometimes this is called a water inlet valve or a mixing valve because it'll mix the hot and the cold together. So if you
Yeah.
hear that term, that's what that is. So we want hot, we turn on one. We want cold, we turn on the other. If we want warm,
Mix
put
it.
on the middle. So the lot of newer ones, the computer controlled ones, have a sensor that senses the temperature coming out, and if it's too cold, they'll shut the cold off and run a little hot. You know, I had a lady in a customer's house had a Frigidaire laundry center. And it was an apartment complex, and she had a problem with the washer. So the apartment complex bought a new. I'll turn off so it's not on record. So they bought her a new washing machine, and she got mad because she put it on cold, and it kept throwing hot water on top of the cold water. And she says, "I don't want that."
Cold water.
But they do that for a reason. That these computer controlled machines have sensors that sense the temperature of the water coming in, and if the water's too cold, they'll throw hot water in there. But this is South Florida. We don't have a problem with water too cold. But if you lived in New York, or I came from Cleveland, Ohio,
Cold.
the washing machines are in the basement. And if you don't run water often enough, the water in your pipes will freeze and bust the water in your pipe, you freeze. So cold water could be almost 30, 40 degrees as it comes into a washing machine. And that is too cold, especially if a customer's using powder detergent. It'll just float on top of the water because it's so cold, it doesn't dissolve and doesn't wash well. So manufacturers, when they went to computerized machines, they put a thermistor, we just talked about it, on the water valve going out, so the control board can see the temperature, and if it is too cold, even if the customer put cold only, it'll throw warm water in there and try to get it to about 70, 75 degrees.
That's cool.
No, it's not.
But not 40.
For here, that's cool.
No, it's not. You don't be in the beach in 70 degrees.
We'll go to the beach 70
So-
degrees. You going to the pool 70?
This is so that the detergent dissolves well. So we're gonna find this in what, a washing machine, right?
Water.
Okay, so we'll put it over here. Alright, so what's this?
It's a push switch,
It's what?
a lead switch, or other lead switch. Or
Well, we already did lid switch.
There is it's a push
This is the dryer door switch
door switch.
for the dryer.
Okay.
The black piece brings down. When you close the door, it hits it, it's closed. When you open the door, it doesn't hit it. 2 more parts. 1, 2. One's for a washer, one's for a dryer.
See, I know. That's for the washer.
You seen one?
I know.
This
I
one or
forgot
that
what
one?
it's called, But on the right, it's for a washer.
Do you remember what that was?
No, I forgot the name of it. But
That's
I
the
seen it.
water temperature selector switch. That
Oh,
is
from the
where
back-
you
the back
as
of
a
the motor.
consumer can choose hot water, cold water, warm water. But not only that, but customers can choose hot water for wash and get a warm or cold water for rinse. Never hot. Never hot in the rinse cycle because it'll cause wrinkles in the clothes, and when they spin out the final cycle, it could stretch them out. So they cool the clothes down so we don't damage them. But this is a temperature selector switch. How you doing? So this is the temperature selector switch. What is this part here?
I never seen
Temporary
one.
selector switch, but
This is a power resistor for a dryer. I'm gonna show you that in the diagram, okay? So any questions on those parts? I'm gonna be a few minutes.
No, I'm just looking. I'm learning
Okay.
myself.
You're coming Wednesday, right?
Yeah. I already told my staff.
I got an email, I appreciate that.
Oh, for myself.
Thank you. All right, guys, what is this machine here? A what?
That's a dryer.
No, but what machine?
It's a dryer.
It's a dryer. We got a heating element, motor, whatever. So let's do this. Let's go here, and I'm gonna take this part, and we're gonna put it on the diagram where all these parts go. Okay? Let me see, Control C. I'm gonna go here, and Control V. Where does this go on the diagram?
to the right.
I'm just making it a little bit smaller.
Okay.
Where does it go on the diagram? Over here?
Right there? No, too far. Go back.
Tell me where. Don't tell me slide and
That big
stop.
circle, that big
What
circle.
do you
It's
see?
that
This one
big-
doing
big
it.
circle in the motor, in the diagram, in the circle.
Drive motor,
In a big circle.
2 windings. Look, how many wires? 1, 2, 3. How many wires?
Three.
3. So that is this part right here.
Yeah.
Okay. What are these here?
Switch.
For what type of switch?
I think those are the timer switches.
No.
But temperature switches.
No. Centrifugal switch. Where do we find a centrifugal switch? Where is it? It's on the motor. That is that black box right on the motor there. It has 2 switches inside of it. This one here and that one there. So all of those pieces are on that motor. Okay? So let's go back here and let's grab another part. Okay, so let's grab this one. Control C.
Mr. Richard, when that part go bad, you gotta change the whole motor?
Yes, sir. Any one of those parts fail, we change the whole motor. Now, this part could go many different places, but where would we put that part?
Timer
Okay.
motor.
Well, that's timer motor, but this is the whole timer. So all these pins are not there. There's only 2 wires at the motor. So where are all these pins connected?
You got
Like-
the timing switch right there.
Okay, so
TM.
time to switch right where?
TM.
Where do you see TM?
Um, right there. TM. Oh, you
On
got
the same line.
on
Where are
the
you
same
seeing
line.
TM? Oh, this?
Same line.
Yeah.
Oh, I'm sorry. So that's a timer switch. So this and
Or it's
this
the
and
orange
this.
line in the
If we
blue
look
line.
close enough to this timer, we're going to see T, M, O, R, and W, B. Let's see if we can read it on there. Probably not.
I see W on the.
That says A. This one's probably B and C. So they probably go by letters. And they would call one switch A, B, and C. So this one isn't exactly this machine. I tried to find a timer. But that timer has multiple switches. So where's the rest of the switches that are in this timer? There's one. Are there any other switches on here?
Yeah, the second switch right there to your left.
This
Right
one?
there.
All right. Oh, by the way, your stove is working. Everything's working on
I
this
have
stove.
another under the motor.
That?
No, under the motor. Under
Oh.
the motor.
Here?
Yes.
Okay, what else?
Yeah, I'm looking.
Oh, switch it
The
off.
singular switch on top of the motor.
This one.
Oh, that's it?
That's
1,
it.
2, 3,
So
okay.
this, and this are all switches, but they are what all these pins are. Now, this is hard for people to understand when we're doing diagrams. Because if you look, the power goes down here and goes into the timer, and it comes out the timer and goes back to the timer motor, and then it goes back to a timer switch, and then it goes over here and runs out. So we're going to the timer motor. So there's a wire connected to here, for example, to a pin. And from that pin, we come out another pin, and that one goes into the timer motor here. This one goes into the timer motor. This one comes out the timer motor and goes to another pin, and then it comes out another switch here. So this, the motor behind here and this are all there. But in the diagram, you don't know where that is. And that's one of the hard parts about diagrams is knowing, I'm looking at this switch, but where is it inside the machine? That's what you need to understand. When you guys are working on these machines and you're tearing them down, you need to have the diagram, and when you're testing it, you have to look and say, well, that switch is that switch there. So when you're out there in the field and you're working on it, you understand where these parts are. Because sometimes it's easy for people to see the circuit going through, following the line, but then they go to the machine and they're like, it's not a straight line. It goes up, it goes down. Wait till you see the washing machine. That's even more crazy. Okay? So I'm going to clear off some of these lines here so we have room for another part. Let's go with that part right there. The buzzer. Where's that at?
Go where it say
This
door.
one.
Hey,
Right,
right to the motor.
Yeah.
All right, y'all just saying it like I have to understand. I have to understand what y'all saying.
Mr. Rich, I got a question about that switch.
Yes, sir. About what switch? The timer?
The timer, yeah.
Yes, sir.
All
What's the
right,
question?
if one of the wires go bad in the timer,
If the timer fails, the whole
you
timer
don't
is
get all
replaced.
just for ask you that. So the whole
We
timer.
don't. Very rarely do we repair a part that fails on the machine. We are parts replacement guys. And can you repair a part? Yes, you could repair a part, but here's the thing. You go to someone's house and let's just say a switch inside that timer failed, and you were able to open the timer up, see the contacts and sand them down and clean them and everything, and get it to work and put it back together. And you didn't charge them the full labor you would have charged if you replaced the
If you had
timer,
replaced it.
and you didn't charge them for the timer, so you're helping the customer out a little bit. But what happens in a month when they call you back and said it's not working again and that switch failed again?
Well, then you gotta replace it now. I mean, well, not you have to replace it. You tell them, hey, I tried.
Okay,
my little.
so how much do you charge a customer? Because you charged them labor for cleaning it already and it didn't last.
Well, me personally, I'll let you know at first.
Okay, but what you let me know, what would you tell me?
I will tell you, okay, look, I can save you right now, but if I come back out, I'm gonna charge you my regular price. Which one you wanna do?
All right, then let me ask you a question. Your regular price is based on what? What are
My
you?
time.
Your time. So you fix it and it fails and you go back again, you lost time. Because you're gonna have to order the timer and you're gonna have to get the timer and you're gonna have to install the timer and you lost money. You lost money on the job. But this is what I'm trying to say. At that point, the switch has failed. It's gonna fail again if you try to sand it down and clean the points and get it to work again. So just replace the timer. Because when you get the timer from the parts house, they're gonna give you 90 days minimum part warranty. So if it fails again, there's no more money out of your pocket, okay? You charge the labor you're gonna charge. Some people say, well, it only took you 10 minutes to change it. Why are you charging me $100 labor?
That's what it is.
It is what it is, but remember, you had the time to diagnose it too. You had to go get the part. Then you had to come back with the part and install the part. So your 10 minutes installing it didn't count for the time you had to go to the parts house and get it, or look up the part, call them and order it on the phone or order on the computer, or go out and diagnose it the first time. But at least if you only go out one time and put that part on, you're almost guaranteed not to go back.
Well, at the beginning, I mean,
You have more chance of going back if you try
Well,
to
if you're trying to
fix
make money out of
something
the person.
than replace. You're not trying to make money out of the person. The labor you're charging is that you're also giving the customer a 90-day guarantee on your labor. And now if you go back, you charge a little more than the time you spent installing it, but that covered your cost for going out.
I got you.
Paul, how many times, Paul, I tell you, you're not charging customers enough money? All the time. That he does work for people and he doesn't charge them what it's worth. And I get it. I feel bad too, charging somebody $100 labor and I was there for 5 minutes.
I know.
That's fine. You have no conscience, I do.
I mean,
But that's not the point.
I mean, I get
But,
it,
but the point is though, is that we have a standard in industry that roughly what we charge customers for certain types of jobs, but you try to be same across the board. If you're just making up the price of a timer job, and let's say you charge them $70 labor plus a part plus a trip charge, it's a total of $275 the whole job. Let's just throw a number out there, right?
Yeah.
And a lady on the next block over calls you out, and you give her the same job for $225. Those two ladies are best friends. And she did the same job and charged me $50 less than charge you. So you have to have a standardized way of charging. Can you charge by the hour? Yes. And if the customer had the dryer on top of a washer,
Just be advised that for technical college students and teachers, there are some food trucks available.
okay, one second, we'll wait for the announcement to
Like
go.
where the buses would pass by normally during the day. You're welcome to go get food if you would like to purchase something. They're waiting to see if any of you are interested. If not, they would be hanging out. So if you would like to pick up something, please, and you have your teacher's permission, go ahead and go now. Thank you.
Okay, so I even lost track. So yeah, the thing is though, is you try to be standardized. It may not even be the lady on the same block. It may be a lady in a different county, but they're sisters.
How she look?
I don't know. I haven't got there yet. That's she gets a discount. Okay. Okay, so let's go with this part here. What is this part?
Operating thermals right in the middle.
It's what?
Operating thermals.
Operating thermostat, because it's the lower temperature. So we're gonna put that part here. Now, let me ask you a question. By me putting these parts on, what am I trying to get at by putting these parts on this diagram? So you guys can understand, like you see it going through a switch and going to another switch and going through a part, but you don't know what those parts really are unless you're familiar with the machine.
Yeah.
Well, when I look at a diagram, I see all those parts. I see everything.
You know that.
I don't need that much. How does a person from Braille read from bumps? You know, they see that, well, they
know.
they know what it is by feeling it. But the point is that you don't need a bunch of words here if you're familiar with the diagram and the product on the machine.
Yeah, when you're familiar with the machine images of the parts, like you say, yeah.
But this is what I want you guys, I don't want you to do this specifically, but when you're working on a part, you need to look at the diagram symbol and compare it with the actual physical part and understand how those two, how the drawing represents that part and understand what that means. Sometimes that switch, let me just bring another part over to the diagram here. Let's go with this one here since we're... Okay, what is this part?
That's high limit.
That's the high limit thermostat, so that's
Right
over
there.
here. Now you notice it has two little pins here. You notice that we got one here, but we got two wires here. That's why it's got two pins. So I'm gonna make it a little bit smaller so it doesn't cover the diagram above, but that's here. So you see power's gotta go into this, out the other side, into this, out the other side to what?
The heater.
Heater, so let's go get the heater now.
So
Yes, sir.
this what about the dryers with the steamer?
Well, I'm starting off simple. Do you think you think I give you that stuff that everybody in here? Some people in this class haven't even opened a dryer yet.
Oh, okay, I'm sorry, because you gave it to me already.
I gave it to you, but you ain't opened up washer. The next diagram is washing machines.
Okay.
I'll get you now.
Okay.
Okay, so that heater relies on this. Where's this at? Did I bring that symbol over or do I need to go get it?
You need to get it.
I need to, where
That's
is
a
it?
push button that you're talking about.
Centrifugal,
So where's the centrifugal switch?
inside the motor.
Inside.
But it's already here.
Yeah. Okay, all right.
So I don't need to get it.
No.
Again, I told you, these two switches are in that black
Good
box.
enough, okay.
I tricked you there. No, you didn't get
Oh,
you
I
on that
wasn't
one.
worried about it.
Okay, so
I wasn't worried.
in this circuit, I've already got the timer, right? I already did the timer switch. I got these thermostats, the heater, got centrifugal switch. What am I missing to complete that circuit? What part am I missing?
Thermal cutoff.
The drum.
The thermal cutoff. The drum is a mechanical
I
part.
know, that's what you.
That's with me. So, where's the thermal cutoff?
There's no one on the top.
Tell me, what does it look like?
The
Next to
third
the
one
one.
to the right.
Next to the buzzer.
Next to the
The
buzzer.
third one to the
That
right.
one.
Third one to the
Nope,
right?
No,
That
that
one.
Right
That
here.
one.
Yeah.
Pero,
Okay, the 309-degree one, right?
okay.
Ah, okay.
No, I thought-
Well,
I thought it was-
you don't have people call me and said, hey, Richard, the operating thermostat, I don't have the actual one for the machine. Can I put any other operating thermostat on there?
No,
The answer is yes and no. Why?
you go overload it.
Well, no,
Or
you could put any other manufacturer's thermostat there as long as they cycle at the same
Oh,
temp.
this in temperature.
As long as if they're 5 degrees different, the customer never notice. But you're not going to put a 250 degree one and a 135 one. But if I had a 140 degree thermostat on my truck, could I remove this and install it on there?
Yeah.
Sure. Will it burn the clothes? No. Because high heat's like 160, 165. So it's still not going to damage any clothes. But yes, could I put an aftermarket thermostat there? Yeah. Okay, so we're going to take the cutoff, right? Did I copy it already? I don't remember.
No.
Let's see, Control V. No, that was the heater. We'll delete that one and go back. I didn't know if I copied it or not. And so that one is right here. So, in other words, that heating element needs this switch, this thermostat, this cutoff, and that switch.
So do that
To work.
operate as a safety?
That is the safety.
Yeah.
That this one here turns the heater on and off.
So the other one is like a fuse.
Okay, but yeah, this one turns it on and off. If this one fails, we rely on this one to cycle the heater on and off. And if this one fails, then we go over here and this is, I'm done. Because this one's 250, this one is 309. Both of those are mounted here on the side of the heating element. They're mounted in these two openings right here. This opening right here is this one, and this opening right here is that one. But they're mounted right on the heater. That's why they're higher temperature. This one is mounted away from the heater, where the air leaves the dryer, what we call the exhaust, and it's measuring the exhaust temperature, not the inlet temperature. This is inlet, where the air is coming in over the heater. But what if we had a problem with air circulation? The outlet one will never see it. If something in the dryer was blocking air from going out, we don't move much air over the heater's going to overheat, and that's why we rely on these parts here, because they're on the heater, backing up if that one doesn't do a job. Okay, so let's put this one back down here. Now, this one had 4 terminals, but if we look at the diagram, there's only 2 here. So is this the wrong thermostat?
Well,
No, you said it was.
yes, unless you have a special feature.
It's another trick question, my friend. It is in the diagram. You guys find out where it is. What? Wait. Before you look for it, what did I say it is? What is those 2 small terminals? What does it do?
It's a heating element.
It's a heating element.
It help it drop the temperature.
Wait. It's a heating element, and where would I find it physically? It's where?
Inside.
Inside what?
Inside the
The whole thing is what?
integrated.
No, the whole thing is what?
Thermostat.
So it's inside the thermostat?
Yes.
So what does it say up here?
There's the heating element that goes to the table.
What does it say? Does it say
Thermostat
heater?
heater.
It says thermostat heater. So those 2 terminals are up here. Even though it's all the same part, diagrams show how power comes in and out the part. These 2 are both inside that one little box. It's just that we have 2 purple wires or violet wires going to the small terminals, and we have a red and white wire going to the bigger terminals. You need to know that in a wiring diagram, they don't draw it where all the same parts are right next to each other. They draw them how power flows through. You need to know where it is in the machine and what it does. Yes, sir. Oh, where did that come from?
So when you touch something, it just went in a circle.
Paul
Well, that's the
cheated.
next diagram. That's the washing machine diagram.
Yeah, I know Paul cheated.
He's trying to trick you.
All right. So we still have a few more parts out here, right?
Yes. The fuse,
Oh, you know what it is? I think the.
I think you put them all on there.
No, the terminal fuse.
Okay, well, let's do this one here. We got a few more parts here. Where is this? What is this?
You said that.
Water temperature selection start switch.
Push the start switch. You just said that.
So where is that?
I can't see the board. There you go, right there. It's right over the timer thing.
It's right above the timer here. I'm gonna make the timer a little bit smaller,
Yeah, right over the top of it.
and that's this push to start relay, right?
Yep.
But I did say there's more than just the push to start. I said it does something else. It
Yeah,
has
you got the actuator for the
Oh.
motor, the lights.
no. But I said it pushes and starts the motor. But I said if you turn it, it does what?
Stop.
Stops
buzz
what?
it, the buzzer.
The buzzer.
Yes, make it
So-
stop the whatever.
So does this have to do with the buzzer?
Oh,
The buzzer's over here, right?
yeah.
That switch right there is on this part too. This is the part that you rotate.
Oh, to rotate the start.
No, you rotate to turn the buzzer on and off. You push to start the dryer. So if you push it, it makes the motor run. But if you turn it, you're opening and closing this switch to here. Now let me ask you guys a question. You notice that everything's nice, black, solid lines connecting all the parts together. This one has a dash line and not a solid line. Why is that?
I forgot to grab.
Let me call Richard. I'm at someone's house. I could call Richard. He'll tell me what it is.
Yeah, call Paul. Hey, shit, I got broken lines. I forgot.
Okay, Paul's gonna get out his number, so if you guys have any questions, but he don't have the answer either, does he?
Well, I'm gonna go to my notes. Or go to the YouTube Academy.
The YouTube Academy?
Yeah.
You think they know more than me?
You own them. You one of the professors.
I know, but if anybody listens to me, they know I don't know what I'm talking about. Okay, that dash line here, that dash line means that if the machine has a buzzer, this is how it would be connected. If it don't have a buzzer, don't worry about it, because the dash line says, if it has a buzzer, this is, it would connect to T on the timer, and it connect to the buzzer, and K, and that's how it would be connected.
So that's a cheaper model.
Well, no, the expensive one is if they have it. The cheaper one is they don't have it.
That's what I'm saying. That's a cheaper model. You don't have it because they got the broken lines.
Now, we also have a dotted line for the lamp.
That's a cheaper model. You got to see it in the dark.
You usually light up your cell phone, right? Okay, so we got this part here. Got a few more parts here. What is that piece?
The plug.
Did this diagram just slide down the whole screen?
Yeah, I forgot that.
Let me move this back up. So what is this, everybody? It's not on this diagram.
Oh, I'll look and see if I see it.
It's a power resistor. This particular diagram, I didn't look at the diagram closely, but if you look at the timer motor has one circuit going here. The power resistor is usually on that line going here. On your basic electricity books, it shows the power resistor.
So that's another safety?
No, it's a resistor to drop the voltage. But see, this timer motor on this machine, if you see the orange wire, it goes to line 2. Okay? Most timer motors are not 240 volts. They're 120 volt motors. So in that case, being a 120 volt motor on that timer, it would go to neutral here instead of line 2. So because the motor's 240, they ran it in line with the heater here, that resistor would be right, let me just,
So they don't act as a safety.
no, it acts to drop the voltage because this would go to neutral and put 120 here, but if we go through the heater, we're on line 2 and it's 240 now.
Gotcha.
So what it does is it drops the voltage down to the motor, puts it in series with the motor. And when you put two loads in series, they share the voltage. And so it's there in some dryers. I'll just go ahead and open it up and show you where it is on that dryer circuit. Give me 1 second here.
So that piece there for just to drop it in series.
Well, that one is there. We use that for a heating cycle. I'm not going to get too deep into it because I want to do more of the components here. But let me just show you that that dryer circuit with the power resistor in there, where it goes on that machine. It was right there. And you can see it here. This one here, if I downsize it, you can see the motor here goes to neutral, which will put it at 120 volts from line 1. Okay? But if I go down this way, when this switch is open, I have to go through the heater to line 2. But that is going to be in series with the timer, so it drops the voltage so we don't burn out the motor.
So what that was, what that symbol at for that?
That's it right there, the power resistor.
Okay, I see.
That's it.
Okay, gotcha.
I was showing you that this diagram had that resistor. I couldn't find a good enough diagram. I could have used this one, but I wanted a different diagram, one that you guys don't normally see every day. And this was in your basic electricity when you all started off in the class, so I wanted something a little different. Let's go back to the program here. So that power resistor would be somewhere here on this line going through the heater if it was 120 volt motor, but we'll leave it there. Okay, we've got a couple more parts for the dryer. Let's do this one here. What is this part? Where is that? On the diagram.
I don't know if I can't see it. Get go up top. It's up top. No, go a
To the
little
right.
over this
To
way.
the right, to the right. Right there.
Right there.
Okay, so let's take a look at this. How many wires are there?
I can't see. Can you
Man,
blow
you
it
guys,
up?
come closer next time. How many wires are there?
3.
3.
3. So if we look here at the door switch, 1, 2, and then if we have a light bulb, the third one.
Well, that's a
So
cheap
that's
dryer.
what that is on the diagram. What?
It's a cheap dryer.
It's a cheap dryer. No, it has the light bulb. We have the machine with the light bulb. But if it don't have it, that. Okay, let's go to another part.
Thermal, yeah. Fuse up there. Thermal fuse.
That one right there. It's the last one. And where's that at?
I thought this one. Oh, yeah, right there.
Right there, thermal fuse. It controls the motor. If that fuse goes bad, the motor don't run. So here's the motor. Here's the thermal fuse. So power goes in to the timer. So it goes into this timer, comes out the timer, goes into the push the start switch. From there, it goes through the thermal fuse into the motor, goes out the motor back to what? The timer. And then from the timer, we go to the door switch and out. So if the motor didn't work, we check door switch, motor, thermal fuse, start switch, and we have 2 contacts in the timer. And that's what we would check if the motor didn't work. Now, I didn't put a temperature selector, but we'll use this same one that we had for the washer. Because I think actually this temperature selector, this actual temperature selector is a dryer one, and I'll show you why in a second. So this one is here. You're like, well, how do you know that's the washer or the dryer? Take a look. It says the lowest setting is about 10 ohms at the highest reading, but on the highest setting, it's 10K ohms. What's 10K? 10,000, right? So if we look at this one here, we got a 6,200 ohm resistor in there, and it's on this terminal and that terminal, and it would be this terminal and that terminal right there. We got 1, 2, 3, 4 in the drawing. 1, 2, you can barely see that 1, 3, 4. But this one here, which is that one, and this one here is that one. There'd be a blue wire here, and whatever color wire that would be, which would probably be violet coming off the other side. So what that does, and there's a violet here. So what that does is it controls the temperature thermostat heater. Remember I said I put 120 to that heater, it's gonna give me low heat. If I put 60 to the heater, it's gonna give me high heat. So that part goes right there.
And that part operate as like a relay?
No, it's just a switch, but it has a resistor inside
okay.
because it controls how much voltage goes here. What did I say about this resistor?
Okay.
It's supposed to
Put
drop
a
the
sync
voltage here. Well, this one drops the voltage there. So if I give it 120, I can go straight through the timer 120. I'm going to get low heat. If that switch is open, I'm going to go through this switch here to the resistor. If I put no voltage to it, I get high heat. If I put 60 volts, medium. If I put 120, I get low. Now voltage to that heater is not the heater that heats the clothes. It's the one that's inside of this box here and tricks the thermostat. I'm going to tell you what I'm going to do. I'm going to save the washer for Monday. I'm not going to do the washer part today because it's going to take a whole nother hour to go over the washer. But all these other parts here on this side, we're going to do on this diagram here. Okay, but I'm going to save that for Monday's class. Does anybody have any questions about this and what we did? So you see what those symbols mean. They mean actual parts in the machine. And we have to know how to test that part and what that part is there for and its function. Okay? And then we'll stop right here. We'll do the washer on Monday.